Hi everyone, my name's Kieran. I'm the technical lead for infrastructure and now security at Redify. Basically, my role within the organisation is to connect developers to the ops and security teams both within our clients and over the last 6 months within Telstra. You may have heard that Redify 6 months ago was bought by Telstra, and it's been a very interesting process to basically bring a development organisation into an organisation like Telstra that has a very ops and security heavy focus. I've seen what works when you integrate these teams together, and I've also seen how the different teams can push each other's buttons and create just complete chaos and nightmares for each other. So we don't really need to go over this slide, but we know that last year was a pretty scary year when it came to attacks. The big important attack though for us in Australia was the incident with the Australian Red Cross. We saw a fairly DevOps centric organisation make some pretty minor mistakes, and that resulted in a backup of a production database sitting exposed onto the internet. 2017 has been equally terrifying in the first few weeks. And as of yesterday, and I haven't updated this slide for yesterday, the world's become a little bit more terrifying. In the first few weeks of January, we saw attackers go after MongoDB, CouchDB, Elasticsearch, and Hadoop clusters. Basically, they're just going in, they're finding open, vulnerable systems and just deleting all of the data and leaving a ransom note. You'd be surprised at how much money they're making from this. Even though there's no chance of organisations getting their data back, they're still paying the ransom on a fairly regular basis. We also saw a DDoS attack take down Lloyds Bank. We've also seen the issues with GitLab over the last few days, where basically an engineer was making some changes and managed to take out, 5 hours worth of production data. Deleted it. Gone. Never to be seen again. And then, of course, yesterday we saw the SHA-1 vulnerability and we saw the Cloudflare issue as well. That's impacted a lot of organisations that follow a DevOps or DevSecOps model as well. Finally, an interesting one, and it's a bit blurry here on this screen, but a 13-year-old piece of malware has reappeared in the wild. SQL Slammer has made a comeback. 13-year-old malware is now back in the wild again. So here we have a representation of the relationship between dev and ops before DevOps. We've got our army here, which is dev, and they're catapulting new builds at the ops team. And they're responding back with a volley of arrows or bugs and issues with the app. Our apps were unstable. Our environments were a complex mess. Our organisations were really quite frustrated with the dev and the ops teams because they weren't moving at the speed they needed to be at. And along came DevOps with this infinite loop of deploy and release and build. It has worked, it had the promise and it has succeeded in that promise of unifying two warring factions, dev and ops, against a common enemy, the users. It's been a success, DevOps. We've seen organisations now moving at a faster pace. We've now got production deployments happening in some organisations every hour. That means a new version is going to be in production in the next hour, and the hour after that, and the hour after that. Gartner made the prediction that 2016 was the year of DevOps, with basically globally 5% of all organisations moving to a DevOps model. HP Enterprise Services, my old employer, they've gone so far to say that in 5 years, DevOps is going to be the norm when it comes to doing an application project, a software development project. But somehow, in the mad rush to get to DevOps, we left out most of the people in this room. We left out security. Organisations really wanted the benefits of DevOps. They wanted the more stable applications, the faster release cycle. But they just missed security. In some organisations where they had formal security teams, they didn't invite you even to the meetings. That's how crazy it was. And there's multiple excuses that you'll hear in an organisation that's got DevOps and are complaining about their security issues as to why they left security out. Some thought it was going to just magically appear there. So how do we go about implementing DevSecOps? Well, there's a few steps that I see as really important. Firstly, we need to have clear communication between the three groups. They need to communicate effectively in ways that they will understand. Their communication needs to be streamlined. We need to make sure that it's really efficient. All three teams are really, really crazy busy. So it needs to be really efficient communication patterns. We need to look at security as code. Look at where security impacts any code that's being written. Training, a lot of people will say it's not important, but overall there is a really great return on investment there. And finally, we need to get some automated security into that DevOps cycle. So we've got our classic three groups, Dev, Ops, and Security. And with DevOps, we realize that development and operations have a two-way street going on. Developers need our ops teams to be able to produce code. The business wants dev to make code. They need operations to provide things like workstations, internet connectivity, so they can Google everything, and all of the other things that they need. Operations to maintain a stable environment. And that's what the business wants, is a stable environment. They need development to start writing high-quality code. And that's something that's often very new to organizations, is the term high-quality code. These two groups often forget that security is their customer. In IT, we're in a customer relationship and a customer management organization. We're basically, all of the users in our business are customers. And Dev and Ops often forget that security is a customer of them as well. It's not just the finance teams. Security, to keep the business safe, I'll use the word safe a lot, need development to write high-quality code, i.e. secure code, to fix the bugs that are found during a test. They also need the ops teams to start doing things like patch management. All simple stuff. The other one that's often forgotten is that development and ops are a customer of security. Devs, operations teams, they often don't understand a lot of the basics of security. They need the support, they need the specialist knowledge that people from the security side of an organization can bring to a project, to a application. So Streamline Communications. We don't use Excel checklists. Excel was designed for financial information. It wasn't designed for checklists and containing large volumes of text information. It's really great for numbers. I recently did a security review. 12,000 questions needed to be answered on 45 different products, all within Excel-enabled macro files. Most people didn't see a problem with that in the security organization I was working in. They didn't see a problem with the fact that their Excel spreadsheet needed a macro enabled to work. Let alone did they understand why I was a bit hesitant to send this out to external vendors. Word documents, they're great to write and present information, but they're really clunky when it comes to doing policies, reports and things like that. It's very hard to tell what the difference was between version 1.15 of a security policy and 1.16 if it's presented in a Word document or a PDF file. If I'm compliant with 1.15, how do I know what the changes were that made 1.16? Do I know if I'm still compliant? And the other one is email attachments. You'd be surprised in large organizations how much security-related work happens via email attachments. And the terrifying thing is, how many of you actually looked at the security of your email infrastructure? Do you have TLS? Do you support PGP? Do you support things like SMIME? Do you have an SPF or a DMARC policy in place? A lot of organizations don't. Don't assume that just because your email servers are secure, that you're about to send a security-sensitive document to a vendor and their email systems are just as secure. So what do we use? Well, systems like this where you've got backlogs and boards, they've worked wonders for agile development, they've worked wonders for DevOps. They allow us to have information presented in a clear way. All of the tasks that a team is working on are listed in this. Security doesn't create a PDF report anymore after a pen test. They instead they create tasks in a backlog. And then collectively, all three will actually work on prioritizing that information. We'll get ownership. We'll get better prioritization within the organization and within the dev teams to start fixing things. Don't overestimate the value of your support ticket systems. I've got Zendesk here because that's the one that I use. For both developers and security teams, it's often overlooked. These systems allow you to have really clear collaboration. There's clear ownership over an issue. You can even automate responses. For all of our security work at Redify, everything comes in from the user side into Zendesk. And then for some things, it's literally just running a macro that provides a standardized text that the CIO has agreed on is what we respond with. You know, dear such and such, stop clicking on stupid attachments, signed IT. And it's pretty much that. The great example is, say you're in an organization, a user goes to put some input into an application, they type some in, they hit the submit button, the whole application crashes. They ring up the help desk, the app's broken. The help desk goes and they do some troubleshooting and they realize, sure enough, putting some input into that field causes the app to crash. Why is that? They'll then go to the operations team who'll go and take a look at it and go, yep, okay. Putting a quote symbol in that input field causes an SQL error. That sounds like a security issue. They'll assign that ticket with all of that troubleshooting information across to security. They validate the security issue. They might put some text in around how to make sure that, you know, some guidance on SQL injection vulnerabilities and application code. They'll assign that over to the dev team who will actually work on fixing the vulnerability. Once they've tested it in a UAT environment, it might go back to the operations team for production deployment. And they might just push the deploy button in TeamCity. That might be all that it is. What we've had, though, is along the way, there's been ownership of the issue. The business and the organization's management can see that this person handed that issue over to here, to here, to here. And the communication back to the user has been effective and clear. They've known along the way that somebody's actually working to fix their issue. The next one, and this is really blurry, is actually it's a piece of technology and it's a language. And it's Markup and Get. Until 6 months ago, I was a bit hesitant about putting documentation into Markup, let alone putting policy documents into Markup. I'm now all for it. Because it means that I can do a draft and then I can send it on to developers, the CIO, and other people in the organization who can start to add extra information in. I can put down a rough guide on OWASP Top 10, and then I can have a Microsoft MVP that's great at, that's an expert in ASP.NET, actually come in and put ASP.NET related examples into my policy guides if I wanted to. But then it's up to me whether that gets pushed out, because I can use pull requests in Git to actually do that review process. And that means from a security point of view, I'm now starting to push a lot of that workload of writing documentation. It's not in my organization, that's back at developers. If they're not happy with something, they need to create the pull request and justify to myself and the CIO why we should make that change. Markup and Get also means that we've got versioning. I can clearly see what the difference was between this version and the next and whether an application is still compliant. It's really effective. And the other thing is it's all free. Security is code. I like to call this all of the code that impacts your security, your organization's security. We've got the obvious. We've got application source code here. But if you're using cloud infrastructure, then your developers or maybe your ops teams are probably using templates like Azure ARM templates or CloudFormation templates. Have anyone in your organization actually bothered to look and see if what's being deployed by these templates is secure? You'll probably find it's not. Server configuration tools like Ansible, Chef, Puppet, Vagrant, and PowerShell DRC have all become the rage right now. Do you know if your developers or your ops teams that have written these pieces of configuration have done so in a secure method? Are they pushing out secure defaults or insecure defaults? So here's an ARM template. It's quite blurry, unfortunately. What this is doing is, this is a small snippet from a template that's from the Microsoft website. And it's actually on Git. People can come and contribute templates as they like. This template deploys domain controllers up into Azure. This piece here that I've cut out is for a network security group. They're basically a firewall ruler and ACL. And it's locking down the access to this machine so it's only allowing RDP inbound. The problem, and it's too blurry for you guys to realize, is that the source address profile is marked as internet. That means that 3389 is exposed to the entire internet. We all know how much fun that's going to be in a couple of days. You may all be shocked at this, but this is actually one of the best templates in that repository. Most of the templates that are deploying virtual machines do not use network security groups. And the fun thing with Microsoft Azure and their V2 networking infrastructure is if you don't apply a network security group, it defaults to any. And that's something that a lot of organizations don't realize. Have you audited your Azure environment to see if any of the automated deployments that your developers are using are doing this sort of shit? PowerShell DRC. Basically what we've got here is a snippet from the DRC configuration that I'm pushing out to every machine in Redify. It's locking down the SSL ciphers. So I'm basically turning off all of the insecure ciphers. And that's why all of our web properties get an A rating on SSL Labs. Can you imagine the effectiveness of just this small piece of code being pushed out to every server in your environment? I'm not just talking about web servers, every server in your environment. Your security is going to go up. Your users' privacy of hitting your web properties is going to go up. The benefits are astounding. And this is just, 10 lines of code to do that change. Not a big, huge push to go and hit every app and argue with every developer. Just a small change by the ops team to push it out to every machine. Training. A lot of people argue still on the value of training. I believe that the return on investment is very, very high. When a developer starts in an organization, you don't just give them the standard, setting a secure password and shoulder surfing training. We need to start giving them specialist training. From day zero, they need to be aware of what the quality expectations are for code written in your organization or by your organization. By quality, I don't just mean that it doesn't crash or it has pretty error messages or log files, but that it's secure, that it supports high availability, that it supports disaster recovery scenarios. That's high quality now. It's not just that the code has the right brackets and the right spacing anymore. It's about security. It's about disaster recovery. We need to make sure within our teams, be it development, security, or operations, we need to have that cross pollination of skills. So that means a developer that might understand some application security vulnerability testing, or an ops guy that can write some OS apps, or a server security guy, that knows the basics of web server deployment or mail server configuration. That means that the three groups are going to more effectively understand the work they're doing and also communicate better. Another important thing, which I'll just touch on, is your senior developers. Get them hands-on training. Hands-on training that looks not just at writing secure code, but actually developing exploits for code. This will give you better buy-in. This will encourage them when they are starting to review the code of the juniors in the teams to actually identify security issues. And that's really important to get that buy-in and that ownership of your seniors. So we're back to our infinite loop of DevOps. So what's the best spot to start putting security in? Well, we often describe security as the strongest link it's as strong as the weakest link in the chain. This is your new chain. You need to secure this chain. And the answer is we want to put security at every step along the way in our DevOps cycle. So when we start to plan, we need to integrate security teams into our planning cycles and our review cycles. This is so that we can start seeing the right architecture in the code. We can start prioritizing those security stories appropriately. We also want to make sure that we consider the security stories earlier on in project cycles. If you've got a 12-month project, think about, say, authentication in the first or second sprints, if they're 1 or 2 week sprints. Don't think about them on the last week of the last month. You're not going to get it done. You're just going to end up with a wide open security model. It's not effective. Get the security teams involved early. And that means if you're security, you need to start attending developer meetings at kickoff. And I know that sounds hard and it sounds boring, but that's just the price of doing business now. At the code phase, well, to get developers writing code, you basically need to have them trained and understand how to write secure code. Also look at things like your development methodologies. Things like test-driven development, where we write our tests and then our code, can encourage better security. Also look at using the right tools. Things like Visual Studio, your Eclipse editors, they have built-in tools or plugins that will alert developers to low-quality code. Not just security issues, but low-quality code issues. Use those tools. Deploy them effectively. And finally, get seniors reviewing code before it gets merged into development or master branches. That way they can find security issues and prevent it from ending up in your development and production environments early. At the build phase, look at static and dynamic code analysis tools. I'm not going to go into what's better, but just remind people that they need to be tweaked. You need to make sure that they're generating alerts that are effective. If you have an alert that might be mitigated by something down the line, then then you need to make sure that you tune those alerts effectively as well. At the test phase, consider security tests. So we all have tests in our organization that go off and test input into our web forms automatically. What about having a test case that tries some SQL injection and just sees what the response is? You can do that automatically. You can capture those errors and start to find issues earlier on. Fuzzing is becoming more important. It's becoming very popular. Microsoft is about to release its cloud-based fuzzing, sort of automated fuzzing solution called Project Springfield. I think the name is hilarious because I can just keep thinking of The Simpsons. It's going to be a very cost-effective model from what they've been telling people about the cost rates, the billing rates, and it's something that could open fuzzing up to a lot more organizations. And I can't believe in 2017 I need to talk about load testing. There's 2 reasons we do load testing. The first is to make sure that our application will handle the load as it's designed. If the app is designed to handle 1,000 users, can it actually handle all 1,000 connecting at once? If not, why not? It's not designed, it hasn't been designed to its specifications if it can't. The second is pushing it to its boundaries, actually finding out what it will take in terms of load to break the application. If you don't believe me on the value of load testing, just ask the Bureau of Statistics. Release and deploy. It's often overlooked at this stage what we can do from a security point of view. Typically in our release cycle, we've gotten all this way, we may have pushed it out to a development environment or maybe a UAT environment. That's a great point where we can start hitting it with automated vulnerability assessment tools. We've got the application installed on a production-like stack. And that means web servers, databases, load balancers, firewalls, and everything in between. Let's start scanning with automated tools and determining what there might be an issue with in the environment. Now, depending on what you find, it might be fine to go into production. But we might want to hold off a production deployment if there's something serious found. The final steps, monitor and operate. Obviously, the ops teams need to do their standard application log file monitoring, checking to see if the application's crashing and why it's crashing. But also start looking at patterns. Is that spike in login traffic caused by a brute force attack, or some sort of credential theft attack, or something going on with a botnet? looking at your IP addresses and going, well, why is this botnet starting to connect for me? Rescan with your automated tools for vulnerabilities. There's a lot of things that you'll find after you've gone to production. A lot of organizations had gone to production with OpenSSL and then found Heartbleed afterwards. So these tools will help you identify new vulnerabilities in your environment. They're also great for looking at security issues that have been introduced by your ops teams at a later date, like enabling directory browsing on a web server. That's something you probably want to alert on. Set up a structured patch process. Something that sounds simple, but how are we going to push a new version of our application to production within, say, an hour, if it needs to be? Finally, track your application dependencies. We're all using Node.js, we're all using NPM packages, they're all within our environment. Do you know if the NPM package that you compiled that went to production last week, has that had a security vulnerability found and fixed this week? Do you know if there have been any? If the application's been deployed for 6 months, maybe it's time to get it, redeploy it, and redeploy it to production. We haven't changed the source code, but those underlying dependency packages have been changed, and they could introduce security vulnerabilities to our environment without us actually doing anything at our code level. That's all for me today. Thank you very much.